Hey guys, UNCC Demola here. We're going to go over how to do a Skidpad model today in Dymola. So we already have a working Skidpad model in Dymola, so we're just going to go to the Start menu. We'll search Dymola, 64-bit. Doesn't matter which one you pick. I always do 64-bit because I'm on a 64-bit OS. So then we're going to say File, Change Directory. We're going to go to, I have a hotkey shortcut to it. We've gone over how to get to the Motorsports Formula SAE 2016 FSAE folder. If you don't have access to this, make sure to talk to Marion or someone in the Motorsports department to get you access to this folder. So I'm going to go into my Dymola folder, select that, then I'm going to open up, it should be the top one because it's most recently edited. This is the whole library that we've developed for the 16 car. Right now there's a lot of extraneous stuff in there, but once we get that, it'll be cleaned up before any of you are using it. So we're going to come down here. First thing we're going to do, we're just going to open up our closed loop test, constant radius cornering. So this is the curvature. I've set the track. This is the radius of the track, the Skidpad track. This is going to be a left-hand turn track. We can do a right-hand turn track also, but for the sake of showing you how to do this, we'll just do the left. Velocity source, this is how I implement the ramp of the velocity. So we are demanding this car to go 12.2 meters per second. That's going to be its magnitude of its velocity. So if the car is slipping or yawing, that velocity will not be applied tangential. That velocity will just be the total velocity of the car, and the car will try to achieve that no matter what, even if it involves spinning around in circles. So you can really test the limit of your car, just the suspension and the weights and the masses, not any of the engine or transmission behaviors affecting the car, or throttle input, braking, etc. So this is really a good bare-bones Skidpad test to give you an idea of your suspension characteristics and your handling characteristics. So the way I have this is that it'll ramp up over a 10-second period of time to help the solution initialize. So you'll not be watching that first or second lap, but the third lap and onward will be good. So we need to call our track. The track is just going to be a visual. Circle for Skidpad. The track is just a visual, so the driver, or there's no driver model here, so the car isn't following the track in any way, but the track is a good way for you to visualize that the car is staying on course. You'll see that with the way we have our car set, I believe this model will run and this one will stay on course, but we'll check. Just zoom out, scroll with the center mouse button. So now you see we have a circular track just defined on a sign, on a circle definition basically. So here we go. I like to do this 50 seconds. I like to use a stiff solver, so that's good. Okay, just making sure that was good. We're gonna hit simulate. If anything crashes, then we'll fix it then, but we should be good to go. So it's just simulating now. Okay, so we can see our simulation is started. It simulates pretty quickly. let's take a look. All right, cool, so our car's on track. I don't like to follow the car with these models. All right, so our model has simulated. So I'm gonna hit run just so we can see what we've got here. So we see the car ramp up to go around. Looks good. All right. So things are looking good. We'll just run it through, just make sure everything looks good. Yep. All right. So you can see it goes around pretty good, even circle. We're lifting that yellow, signifies we're lifting that inside rear tire. Right now, at this point, we don't have the rear geometry from the 2016 car model. The rear is from the 2015 car, which did used to lift the rear, lift the inside tire. So we'll see. You know, we'll see how it's like when we got the 16 car in there. But the other thing I want to show you, once we have this model run, then we have a command called plot skidpad point of interest. Run that. That's going to just output some important values, mainly our forces, velocities, position of the vehicle in the world frame, etc. So what you want to do, because we're going to export this for a lap timer, and eventually there will be some other tools involved in MATLAB too, but just for the time being, we have a lap timer. So you're going to go here, right click, constant radius cornering, over here in the variable browser, export result as, and then say, make sure you've got the plot that says, let's see if we can, oh okay, I'll go back out just so I can show you. All plots for export selected. So make sure that one's selected. Go here, constant radius cornering, export result as, result files only plotted .mat, and then go here. You're going to open up the folder, export to MATLAB, and then go ahead and call it, I like to call it results from Skidpad, and then the date. So today is 04/01/2016. So do that, and then before you do that, just hit Control C so you have that text in your clipboard. Hit save. And then we're going to go into MATLAB, which I already have open, and you're going to go into the editor. And you're going to open, got something else open that I've been working on. You're going to go ahead to go open. I believe that I've saved my program. Yes, so we're going to go and use the Dymola lap timer here in the export to MATLAB folder within the Dymola subdirectory. Going to click that guy. We're going to go ahead and load what we just called it, right? So just change that. Okay. We're going to change folder, hit run, and there you go. So we're running a 5.6. This is our this is just an initialization error, and then this is our warm-up lap, and then we're running a 5.6. That's a pretty good lap. I don't see any reason to complain about that. That put us about 17th or 18th in the field last year. So there you go. That's the DymolaSkidpad model. Basically, you can get some good, you know, estimation of the vehicle's behavior, overall behavior. You can easily go in here and change the and you can change parameters on the car. So we could go in here, we could demand a little more velocity. I think that's about all we can get out of it. Big change you can make here is body mass changes. So you go in here to masses. It's being slow right now. Mass and inertia, moving around the center of the mass of the car. Those kind of things. So clicked something weird here. Let's go back there. There you go. Parameters. There we go. There's our mass. Center mass, other masses, etc., etc. Alright, so that's how you do the Formula SAE Skidpad model. Hopefully this was a helpful tutorial. And if you have any questions, feel free to send us an email or post a comment on the YouTube videos. Thanks.